Welcome to the Chapter 6 Part 1 video. As a disclaimer, as I mentioned in class, Chapter 6 is only 2 parts and it's the only chapter we're covering this week, so the test will be on Wednesday. There's also no school on Friday. So 6.1 and 6.2 are covered in this video, and then there's only one more video for the week. So Chapter 6 is talking about polygons. Polygons are shapes that have sides that close in on each other. So for example, a triangle or a quadrilateral. So our objective for this section is to find the sum of the measures of the interior angles of a polygon. We already know that for a triangle, but we're talking about for any polygon now. And to also find the measures of the exterior angles of a polygon. Okay, so remember, interior means inside of the polygon, exterior is created by extending one of the sides. So let's formally define what is a polygon. A polygon is a closed shape of segments which intersect only at their endpoints. So it can be however many segments you want, but they have to intersect only at the segment endpoints. So they cannot cross like this. That is not a polygon because they crossed in the middle of the segments. Okay, and another example that could not be a polygon is something like this because it does not close, right? So this is, again, not a polygon. Okay, if you remember from triangles, we said that equilateral means the same sides. So this means all sides are congruent. All of its sides are congruent. Same. Angles, which means all angles are congruent. Now we had a special case in triangles that if it's equilateral, that it's also equiangular. That is not the case for polygons greater than 3 sides, okay? But if it is both equilateral and equiangular, then we say that it is a regular polygon. So if I have a 4-sided figure where the sides are all congruent, that would be equilateral. That does not mean that it is also equiangular. If I have a 4-sided figure that is equilateral and equiangular, then I would say it is a regular 4-sided figure or a regular quadrilateral. So let's look at some of the special names that we have for polygons with a certain number of sides. So we've seen with 3 sides, that is a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is like a stop sign, is an octagon. 9 sides is a nonagon, also called an enneagon. Almost always it's called a nonagon, but you might see it referred to as an enneagon sometimes. 10 sides is a decagon. 12 sides, 12 is 10 and 2. So do for 2 and deca for 10. 12 sides is a dodecagon. And anything other than that, we'll just call it an n-gon. Sometimes it's called an enneagon. And that just means n number of sides. Okay. So if we remember back to our triangles last week, the triangle sum theorem said that the sum of all interior angles of a triangle, and that's important just for a triangle, is 180 degrees. And that's only for a triangle. If I have a different number of sides, then the interior sum will be a different number. Okay. So let's look at, well, how can we find the interior angle sum for other shapes? We have a formula for it, and it is that the sum of the measures of the interior angles of any polygon with n number of sides is 180 times n minus 2. Okay, so in our example here, n has, and I like to mark on the sides to make sure I counted them, 1, 2, 3, 4, 5 sides. So the sum of the interior angles will be 180 times 5 minus 2, which is 180 times 3, which equals 540. 540 degrees. Let's talk about where this formula comes from. So if we look at distributing this formula, we'll see that by distributing the 180, you get 180n minus 360. And the 180n comes from, I'm going to do this in a different color so that you can see where this 180n is coming from. It comes from if I make each of these sides into a triangle, then I have 5 triangles, right? So that's 180 times 5 for the 5 triangles. But if I'm looking at the interior angles, that does not include these angles in the middle. And so if I take all of those angles, that's 360 degrees. So then we have to subtract the 360 degrees from the middle in order to get just the interior angles of the pentagon. Okay, so that's where the formula comes from. So if you ever get stuck and you're like, wait, I don't remember what the formula is, you can go back and you can derive it by looking at triangles. Split your shape into triangles and then subtract out the angles that are not part of the angles that you wanted to measure. So let's do a couple of examples. In example 1, we want to find the value of x. Well, we see here we have a 4-sided figure. So we can say the total angle sum should be 180 times 4 minus 2, which was 180 times 2, which is 360. Which means that all 4 of these angles should add up to 360. So I have x plus 71 plus 135 plus 112 equals 360. Subtract all of these, minus 112, minus 135, minus 71. So then x equals 42. This should be an x equals 42 degrees. In number 2, we're going to do something similar where we have all of our angles here. We need to find y. So the first thing we need to know is how much should these add up to? And so we say this is 1, 2, 3, 4, 5, 6 sides. 6 sides gives me 180 times 6 minus 2. 180 times 4 is 720. And that's our total. And so then we're going to take 720 minus the ones we know in order to get y. So we say minus 127, minus 106, minus 119, minus 142, minus 113. And we get that y equals 113 degrees. Okay, let's look at a couple more examples. For number 3, we want to find the sum of the angles for a decagon. Deca is 10, like a decade or a decimal. Dec means 10. So to find the angle sum, 10 sides means we're going to do 180 times 10 minus 2, which is 180 times 8. Put that into the calculator, you should get 1,440 degrees. This time we weren't looking for a specific angle, we were looking for the sum. So we're going to leave it with the 1440. Okay, and our last one, number 4, we could call it find the value of each variable. So now we have 2 variables, we have y and z. So we can't use adding up all these angles because there are 2 things we don't know. However, we can still use everything we learned in the previous chapters, such as that linear pair. So the first step is going to be to use the linear pair to say that z equals 180 minus 106, giving us 74. So now that's 74 degrees equals z. I can find y by saying this is a quadrilateral. If you look back at number 1, we found that the angle sum for any quadrilateral will be 360. So 2 quadrilateral sum is 360 degrees. So we say 360 minus 74 minus 87 minus 94 equals 105 degrees, and that is y. Okay, so if we can find any given angle, if we're looking at a regular polygon, remember a regular polygon means all of the sides and all of the angles are the same. They're all congruent. So all of the sides are congruent to each other. All of the angles are congruent to each other, which means if all 4 of these angles were congruent, I could take my angle sum and divide it by 4. And so for any n-gon, any regular n-gon, we can take the total of our angle sum divided by the number of angles. So this is the total angle sum divided by the number of angles. So in order to use this, we have to remember that regular means that it is both equilateral, all the sides are the same, and equiangular. Same sides and same angles. And one does not mean you have the other unless it's a triangle. So let's do a couple of examples. In example 1, or part 1, is the given figure a regular polygon y or y not? So if I'm looking at this, what does a regular polygon mean? It means that all of the sides are congruent and all of the angles are congruent. These angles are not congruent, so no, the angles are not congruent. Without having to do any calculations, we didn't have to find y, but we just know if the angles are not congruent, then this is not regular. Part 2, given that the figure is a regular pentagon, so we know that all 5 sides are congruent. We know that all 5 angles are congruent because of that word regular. Find the value of each interior angle. So in order to do that, we need to know how many angles there are and also their sum. So we can say 180 times n minus 2 gives us the angle sum, divided by how many angles there are, and this time n equals 5 for a pentagon. So we have 180 times 5 minus 2 divided by 5 equals 180 times 3 divided by 5, which equals 540 divided by 5, which gives us 108 degrees. which means that each angle here is 108 degrees. That does not tell me anything about the side lengths. So that does not mean that the sides are also 108 units long. It only tells me about the angles. So let's use what we know about exterior angles to see if we can draw an exterior angle of the polygon. Let me draw the polygon. Okay, so what we want to do is draw an exterior angle at each vertex, and what that means is going to the vertex and extending one of those sides. So there's the exterior angle. And we want to do that for each vertex. Now, it doesn't really matter which direction, which side we decide to extend. It will be the same angle measurement for the exterior angle. And why is that? Well, we know that both of those exterior angles are supplementary to the interior angle. So it doesn't matter which side you extend. You just want to extend one side for each vertex. Okay, so extend one side at each vertex. And then we want to find out what is the sum of all of the exterior angles of the polygon. Well, in order to find the sum of the exterior angles, we need to know what all of the interior angles are. And we have 4 of them, but we're missing one. And so we say, well, okay, we need to find that angle measurement first. We need to find measurement of angle y, which is going to be the angle sum. This is a pentagon. Well, we just found the sum for a pentagon to be 540. 540 minus the ones we know, 110, 90, 120, 150. And what we end up with is 70. So we found the last one to be 70 degrees. Now we can find all of the exterior angles. So our first step was to find measure of angle y using angle sum. And that's our 180 times n minus 2. We had already calculated it above. And then our second step is to say 180 minus each interior angle because they're supplementary. So for example, at angle O, these two angles are supplementary. One of them is a right angle, which is 90 degrees. So the other also has to be 90 degrees. Angle T, they have to add up to 180. So 110 plus 70 gives me 180. 120 plus 60 is 180. 150 plus 30 is 180. And 70 plus 110 is 180. Okay, now it doesn't ask for this, but I can notice how 110 and 70 appeared twice, which means that these lines are actually parallel. That means this was a transversal of parallel lines by the inverse of the alternate interior angles theorem postulate. Okay, so we found all the exterior angles. What is their sum? So step 3 is to add them all up. Add them, and we get 70 plus, notice it says today, so I'm just going to put them in that order. T, O, D, A, and Y. Just the exterior angles, the ones on the outside. So which ones are exterior? It's going to be these ones. And if we add all of those up, you should get 360 degrees. Now think about, if you take this pentagon and you kind of collapse it in on itself, wouldn't this make a full circle? It goes around in a full circle. And so that's why the exterior angles make 360 degrees. So we have a polygon exterior angle sum theorem. The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. So we can say, and it doesn't have to be a pentagon, it could be any polygon, 6-sided, 7-sided, 200-sided. The exterior angles, 1, 2, 3, 4, and 5, will always add up to 360 degrees. Let's look at some examples. For example 3, part 1, we want to know the measure of angle 1 in a regular octagon. Regular means that all 8 sides are congruent. All 8 angles are congruent. Well, if the interior angles are congruent, then all of their exterior angles are also congruent because they're all supplementary to congruent angles, right? So angle 1, 2, 3, 4, 5, 6, 7, and 8 all have to be congruent. And so we can say the measure of angle 1 equals, they all add up to 360, and they're all congruent, so I can divide them by how many there are. So similar to the interior angle finding calculations, but this time the exterior angle sum is always the same. The interior angle sum is different depending on how many sides your shape has. The exterior angle will always be the same. And so we have 360 divided by 8 equals 45 degrees. And that means every exterior angle on a regular octagon is 45 degrees. If we look at part 2, we want to find the value of x. Here we are given exterior angles. Notice all of these angles are on the outside of our polygon. And therefore, we can add them all up to our exterior angle sum of 360 degrees. So we have x plus 2x plus 3x plus 4x equals 360 degrees. So that's 3, 6, 10x equals 360 degrees divided by 10, x equals 36 degrees. I didn't have to find all the angle measurements, just x. So then we're done with that one. In part 3, the sum of the angle measures of a polygon with n sides is 1,260. Find n. Okay, well, this can't be exterior angles because exterior angles always adds up to 360. So we know this is the sum of interior angles. The sum of interior angles is 180 times n minus 2. But in this case, we already know that that equals 1,260. So now we need to solve for n. Now you can divide by 180 immediately. Right now you could do that, or you can distribute it. I'm going to distribute it because I think that's what most of you would do. So we have 180n minus 360 equals 1,260 plus 360 plus 360. 180n equals 1,620. Divide by 180, n equals 9. And lastly, number 4 for this section, the measure of exterior angle of a regular polygon is 36. Find the measure of an interior angle, then find the number of the sides. So we know this is a regular polygon, and the exterior angle is 36. Find the measure of the interior angle, that's step 1, and then find the number of sides is step 2. Okay, so if I have a regular polygon, if I have an exterior angle, if this is 36 degrees, the interior angle must be supplementary to that. So step 1, the interior angle is 180 minus 36, 144 degrees. Interior angle. Step 2, find out how many sides there are. Now we can do this by using the interior angle measurement, or we can use this by doing the exterior angle measurement. I'm going to show you the exterior angle measurement. So we know that the exterior is 360 divided by n, and it is 36. And so if we multiply both sides by n, this gives us 360 equals 36n. Divide by 36, 10 equals n. So that is a 10-sided figure. Okay. The other way to do it, I'll just show you how you would set it up. Similarly to before, we have 180 times n minus 2, but this time we have a single interior angle, so then we divide that by n equals 144. And you would solve that, and you would also get that n equals 10. Let's take a look at section 2. In section 6.2, we're talking about a very special type of polygon, specifically a parallelogram. And a parallelogram is going to be a four-sided figure or a quadrilateral with very specific properties. And our objective for this section is to use the relationships among the sides and angles of parallelograms and the relationships of the diagonals. So the sides, the angles, and then diagonals, which we'll talk about. So what is a parallelogram? A parallelogram is a quadrilateral, four sides, where both pairs of opposite sides are parallel. So that tells me that I have AD parallel to CB in this picture, but also that AC is parallel to DB. Okay, so when we're writing parallelograms, instead of writing out the whole word, we have this symbol right here. It looks like a rectangle that's a little bit squished. It means parallelogram. And so if you see that symbol, the parallelogram symbol, you can assume that the shape is a parallelogram. If it just says quadrilateral ADBC, then you cannot assume that it has the parallelogram properties. Okay, so we want to list in parallelogram ADBC, list the pairs of opposite sides, sides that are across from each other and not touching. So that would be segment AC is opposite segment BD or DB. And also we have segment AD, which is opposite from segment CB. Okay, for a parallelogram, we know that these are parallel. So AC is parallel to DB, and AD is parallel to CB. In parallelogram ADBC, list the pairs of opposite angles. So we're looking at now angles that are across from each other. So we have angle C is across from angle D and across A to B, angle A and angle B. Now, if you remember back to our properties from transversals, we could say that angle D and angle B are supplementary because those are consecutive angles. Angle A and angle C are supplementary from consecutive angles. A and D the same, C and B the same. And what happens when you set up all four of those relationships is that angle C and D have to be congruent. Angle A and B have to be congruent. So opposite angles are congruent. In parallelogram ADBC, list the pairs of consecutive angles, angles that are next to each other. Not adjacent angles, but consecutive angles. So that's angle A and angle D, and angle B, angle B and angle C and angle A. And we know by consecutive angles that these are supplementary. In parallelogram ADBC, draw a line connecting angle A to angle B. This segment is called a diagonal. A diagonal connects two vertices that are not connected in a polygon, so it works for any polygon. In parallelogram ADBC, there are how many diagonals? Well, we have AB. We also have CD. So there are two diagonals, AB and CD. So let's look at some of these properties. Now, some of these we've already discussed, but it never hurts to repeat them because you're just learning them. So you should repeat them as often as possible. In a parallelogram, opposite sides are parallel, but they are also congruent. So this is a nice property that comes out of a parallelogram. Because of all of the symmetry that we have from parallel sides, opposite sides turn out to be congruent. So we have MA congruent to TH, and we have AT congruent to MH. In a parallelogram, opposite angles are also congruent. So we have M congruent to T and A congruent to H. In a parallelogram, consecutive angles are supplementary. So that means we have X and Y, we just said were congruent, or sorry, X and X are congruent, Y and Y are congruent. X plus Y equals 180 degrees. And in a parallelogram, diagonals bisect each other. So that means that we have two congruent segments, and on another diagonal, we have two congruent segments. So we can say MI is congruent, sorry, these should all be segments. Angle, angle, okay. MI is congruent to IT. AI is congruent to IH. Let's look at some examples. Okay, example 3, part 1. In the parallelograms below, find the missing values. So notice here it says parallelograms. We can't assume that a shape is a parallelogram unless it gives us enough properties or the actual word parallelogram. So if it gives us that the two opposite sides are parallel, then we can say it's a parallelogram. Otherwise, we need to know that it's a parallelogram in order to use all of those properties. So first we're going to say we want to label the two missing sides. What are the properties? Well, since this is a parallelogram, I know that opposite sides are parallel, but we also know that opposite sides are congruent, and that's the one that we want to use here. Being parallel does not mean that the lengths are the same. Being congruent is what means that the lengths are the same. So we're going to say opposite sides are congruent. So that gives us 10 and 16. In number 2, we want to label the missing angles. Well, we only have one angle, so we can start off by saying because this is a parallelogram, and I'm going to go ahead and mark which sides are parallel in order to show that we know it's a parallelogram. So parallelogram has opposite angles are congruent. Opposite angles are congruent. So we have 135 degrees for that angle. But to get these other angles, we have to use a different property, which is that consecutive angles are supplementary. And so we need 135 subtracted from 180 to get 45 degrees. So that's 45 degrees, and this is 45 degrees. And now we have all four angles. For part 3, we want to find the values of x and y. In this case, we're not looking at the side lengths, we're not looking at the angle lengths, we're looking at the diagonals. And what we know about the diagonals is that diagonals bisect each other. Diagonals bisect each other. And what that tells us is that each diagonal is split into two congruent pieces. So x has to be 8 because it's congruent to 8, and y has to be 12. For number 4, we want to know, this time we want to know if it's a parallelogram. So how can we tell that this is a parallelogram? Well, we could check if the opposite sides are parallel. We're not given any indication of whether or not these are parallel. So then we need to use some properties. Every parallelogram has opposite sides congruent. So these two are congruent. That matches our properties of a parallelogram. However, these ones are not congruent, and therefore this cannot be a parallelogram. Opposite sides are not congruent here. So it cannot be a parallelogram. Let's look at our next example. So here we want to solve for the variable and justify our reasoning. We know that this is a parallelogram because it just told us, and therefore these opposite sides are parallel, but they are also congruent. And therefore we can say 2x equals 10, divide by 2, x equals 5, and also y plus 2 equals 16, minus 2, y equals 14. Why can we do that? Opposite sides are congruent. For number 2, we have parallelogram BRAT. We know that it's a parallelogram, therefore we know that opposite sides are parallel. That is our definition of parallelogram. Not the congruences, not the supplementary. Those are properties. The definition is that opposite sides are parallel. Since opposite sides are parallel, we have a property that opposite angles are congruent. So we can say 4 times p plus 3 equals 136. Like before, we have an option here. We can divide by 4 or we can distribute the 4. Since we distributed last time, I'm going to show you the way to divide. If we divide by 4, 136 divided by 4, p plus 3 equals 34, minus 3, p equals 31. Now, why can I divide by 4 and I don't have to distribute it? Because p plus 3 is one factor. That's one number together because it's in parentheses. Okay? If I did not have parentheses there, I couldn't do that. And so if that was confusing, go ahead and distribute the 4 and then continue solving the standard way. You'll subtract and then divide. Number 3. Here we're looking at properties. We have opposite sides are congruent. We know it's a parallelogram because the opposite sides are congruent, right? So now we can use that backwards. And so we can say it's kind of the converse of opposite sides congruent. Because this time, instead of going from parallel to congruent sides, we're going from congruent sides to parallel. And therefore, we can set up the diagonals bisecting each other. So we can say diagonals bisect, which gives us our two equations. G plus 7 equals 15, minus 7, G equals 8. And our second equation, N minus 8 equals 12, plus 8, N equals 20. That might be an H. It might be an N. If you like H better, you can just make it an H. Okay, number 4. Here we have two pairs of parallel sides, so we know this is a parallelogram. Again, we have an angle, one angle measure and two with variables, so we're going to have to set up two equations. We know that first, opposite angles are congruent. So that tells me that y equals 42. And second, consecutive angles are supplementary. And so 42 plus 2x equals 180 minus 42. 2x equals 138. Divide by 2. X equals 69 degrees. All right, let's see if we can write a proof. So now we've seen these properties. We know how to apply them, hopefully. So let's see if we can apply them in a proof. So we're going to start out with what was given to us. And what's given is that OP is parallel to RE. OP parallel to RE. We also know that OR is parallel to PE. And we know that RO has a length of 6. No line over that one because that one's a measurement. That is given. Because I have two pairs of parallel sides, I can say that ROPE is a parallelogram. That is by definition of parallelogram. Okay, congruent sides, again, not a definition of parallelogram. Congruent angles, not a definition of parallelogram. The definition of parallelogram is opposite sides are parallel. Because this is a parallelogram, I can say that RO is equal to PE. RO is equal to PE because opposite sides are congruent. Opposite sides of a parallelogram are congruent. And because RO is equal to PE, I can substitute 6 equals PE. That's substitution. I'm going to call it transitive actually because they were both equal to RO. RO is 6, RO equals PE. So this is transitive. Transitive property of equality. And one more step here. You wouldn't need it if you had put your equation the other way, if you did PE equals RO. But because we have PE first, we need to flip this equation to PE equals 6. And that is symmetric property of equality. Now, normally I do this proof without that step. However, I'm noticing a lot of us want to use the symmetric property of equality for other things. So I'm going to try to include it more in our proofs so that we can get used to seeing what it does. Okay, let's look at a few more examples. In this proof, we're given that GENT is a parallelogram. We also know that the measure of angle E is 3x plus 17 degrees, and the measure of angle T is 5x minus 17 degrees. So I'm going to go ahead and mark here. Parallelogram means that EN and GT are parallel. Also, GE and NT are parallel. We have that angle E is 3x plus 17 degrees. We also know that angle T is 5x minus 17 degrees. Because this is a parallelogram, I will be able to say that angle E is congruent to angle T. So maybe that's where we should start. The measure of angle E is congruent to the measure of angle T. So we had our given, and now we have opposite angles of a parallelogram are congruent. If our opposite angles are congruent, then we can substitute their measures. Sorry, with the measure, we don't need the congruence. The measures are equal. So we can set these equal to each other. Angle E is 3x plus 17 equals angle T is 5x minus 17. That is by substitution. That is not by transitive because it wasn't two things equal to the same thing. This time I was taking what's equal to the measure of angle E and substituting it, and also substituting, so I substituted on both sides. If I'm only substituting one side with something that's exactly one side of something else, that's transitive. I'm replacing one whole side. This time I'm replacing both sides, so it has to be substitution. Okay, step 4, we can use the subtraction property of equality. Subtract 3x from both sides. 17 equals 2x minus 17. Now we want to bring the other 17 over, but that's not subtraction, that is addition. Property of equality. And so we have that 34 equals 2x. Divide both sides by 2, so that's division. Property of equality. And so we have that 17 equals x. But again, we want x to equal 17. So I'm going to add in that step to demonstrate the symmetric property of equality, where we can write it instead of x equals 17 as, or instead of 17 equals x as x equals 17. So we're just switching which side of the equation they're written on. That is what the symmetric property of equality does. Continuing on to our last set of practice problems here. For number 1, we want to find x and y for each figure, for what values of x and y each figure is a parallelogram. Okay, so here what we want to do is we want to look at our figure and say, if our sides are parallel, what do we know about these angles? Well, if we have parallel sides, then this angle and this angle form alternate interior angles, and therefore they must be congruent. So we can say by alternate interior angles of parallel lines, 4x minus 1 equals x plus 38. I'm going to switch to pens. That my black pen is leaking. Minus x plus 1. 3x equals 39. Divide by 3, x equals 13. In number 2, now remember we are saying what would make this a parallelogram. So we're saying if these sides are parallel, what properties must we have? Well, we have that diagonals bisect each other. Diagonals bisect each other. And therefore, we can say that both halves of the diagonals must be equal to each other. So y minus 1 equals 2y minus 7. So then we say minus y plus 7. 6 equals y. For our second pair of diagonals, we have that 2x equals 4. Divide both sides by 2, x equals 2. On number 3, again, we are assuming if this is a parallelogram, what properties do we have? And so we can say that opposite angles are congruent. Opposite angles are congruent in a parallelogram. So we have 4x minus 21 equals 3x minus 4x. Negative 21 equals negative x. Divide both sides by negative 1. X equals 21. For our second pair of opposite angles, we have that 3y equals y plus 78 minus y, 2y equals 78. Divide by 2, y equals 39. 39. And number 4. So again, we are assuming if these are parallel, then opposite sides are congruent. And angles, so those are not opposite angles, those are consecutive. Angles are not congruent, but supplementary. So let's start with the opposite sides. That's 3m minus 12 equals m plus 7 minus m plus 12. 2m equals 19 divided by 2. M equals either 19 halves as an improper fraction or 9.5 as a decimal. If it does not specify what format to put your answer, always put it in an exact form. So in this case, either form is exact. If I have to round the decimal, I would always choose to leave it as a fraction unless otherwise specified. Okay, so that's our opposite sides. Now for our angles, we have that 3x plus 8x plus 15 equals 180. That's 11x plus 15 equals 180 minus 15. 11x equals 165 divided by 11. X equals 15. And so I'd like you to write a summary of the statements of properties of parallelograms that you can put here in a way that you understand it. So for example, I might do a diagram and then put the properties in words as well. But I want that to be somewhere that you can refer while you're studying to remember where, what properties are for a parallelogram, because we will be learning about other shapes that have similar and different properties. So I want you to have somewhere you can go to make sure that you're keeping them straight.